Hi guys, good evening. Can you hear me? Hello. Can you hear me? Hi guys, can you hear me? Hello. Yeah, thank you. So let us start session. Yes, yesterday Java, that introduction discussed. Yes, 82. Yes, that all that introduction completed. So Java history. Yes, 95 to 1995 to today. What is happening in Java? Yes, discussed. Yes, today topic is about these features. Yes. See JDK 1.0, first version of Java, released with these features. First one, independent of platform. Next, portability, group language, scalability, and security. So first version of Java released with these features. Let us see all these features. Yes, independent of platform is OS. Independent of operating system. Portability means running on every OS. Object-oriented programming language. There are some features like this. Yes. 1 second. To understand these features, is some basic knowledge required. To understand all of these features, some basic knowledge like about OS. What is OS? Operating system. Yes. About operating system knowledge. Yes. Operating system, how it's working here. Platform is OS. Yes. How OS is behaving. When Java program running, how OS is behaving. That OS behavior. OS behavior. So operating system. Yes. Next step. Yes. About interpreter. Yes. About interpreter knowledge. About yes interpreter. Yes. Interpreter knowledge. Next about compiler knowledge. About compiler, interpreter and compiler. Yes, Java. Yes, based on what interpreter or compiler. That knowledge. That knowledge. Yes, operating system, interpreter. Yes, next compiler. And next, yes, exe file knowledge. What is exe file? That exe file knowledge. Next, dot plus file knowledge. Yes, this knowledge. Yes, about OS knowledge. Yes, about interpreter knowledge. About compiler knowledge. Exe file dot plus file. Yes, once you have this idea, then easy to understand these features. Yes, to understand all those features here, yes, you must have these basics, this basics knowledge. Once you have this basics knowledge, then easy to understand Java features. Easy to understand Java features. Okay. Yes. Yes, let us start here. Yes, let us start with these basics here. Yes, before going to all these features, let us see all of these features here. About ways, what is interpreter, next compiler, executable dot as well. Once you complete it, next we can move to these features. Okay. Yes. See, I'm starting with basics. Yes, even non-IT background case also can understand. Everyone can understand. I'm starting with the very basics. Okay. From the scratch, starting from the scratch. Okay. See, computer where is starting from very scratch. Yes, starting from very scratch here. Very scratch. Yes. Yes. Starting from the scratch here. So computer web. Very basics. From that we'll go to I&A. So computer web. See, computer web basically two categories. First one is hardware. First one hardware. Next one software. Hardware and software. Hardware and software. Okay. Hardware. These are physical components of a computer. Hardware. These are physical components of a computer. Yes, we can touch all the parts. Hardware parts we can touch. Okay. But this is not our part. We are a software engineers. We are software, right? So our part is software. Ours is software. Okay, ours is software. So let us see about software here. Yes, let us start with software. So what is a software? So what's a software? What is software? Yes, we are the software engineers. So starting software. See software. In software, yes, everything is a program. In software, everything is a program. In software, everything is a program. Everything is a program. Yes, it's a collection of programs. Yes, it is a it's a collection. It's a collection. It's a collection of programs. It's a collection of programs. It's a collection of programs. Collection of programs like C, yes, C++, yes, next Java, yes, Python, like this different programs. It's a collection of programs. Yes, all of this collection of programs. Software, yes, everything is program. In software, everything is a program. Yes, it's a collection of programs. It's a collection of programs like C, C++, Java, like this, all the programs. Okay. Yes, software basically, yes, in the software basically, yes, basically two categories. Software basically two categories. Two categories. Software basically two categories. First one, yes, system software. System software. Next one, application software. System software. Next, application software. System software. Yes, application. Application software. System software and application software. Okay. One second. Yeah. Software basically two categories. Two categories. First one, system software. Next one, application software. Yes, what is system software? So first of all, about system software. So what is system software? System software. See, system software. Yes, it interacts. It interacts with hardware components. It interacts with the hardware components. Interacts with hardware components. The system software. It interacts with hardware components. Hardware components. Okay. Yes, for this example, system software example, ways. Yes, ways. Yes, operating systems. Operating systems. Yes, operating system and device drivers. Device drivers comes from this category. Device drivers. Device drivers. So device drivers. Ways and device drivers. Okay. Fine. Yes. Yes. Today about Java features. Yes, just repeating once again. Today topic is Java features. Yes, independent of platform, portability, hoop language, scalability, and security. Yes, to understand all of these features, first of all, some basic knowledge required. To understand these features here, some basic knowledge about ways, about interpreter, about compiler, execl and dot as well. Once you have this knowledge, then easy to understand all of these features. So I'm starting from the basics, starting from the scratch. So computer web. Yes, even non-IT guys also can understand very clearly. Yes, computer web. Basically two categories, hardware and software. Hardware and software. See, hardware, these are physical components of a computer. Physical components like keyboard, monitor, mouse, hard disk, and all the hardware components. But this is not our part. Hardware is not our part. Ours is a software. So let us start with software. Software. See, software, in software, everything is a program. Everything is a program. In software, everything is a program. Yes, it's a collection of programs. Software is a collection of programs like C, C++, Java, Python, and others here. Software basically two categories. Software basically two categories. First one, system software. Next one is application software. System software. system software, next application software. System software, application software. Yes, what is system software? System software, it interacts with hardware components. Interacting with hardware components. System software interacts with hardware components. Okay, example, operating systems and device drivers. Operating systems and device drivers. Okay, next application software. So next about application software. So what is application software? See application software. See application software. Yeah, this is for the purpose of application development. Application software. Yeah, this is. Yes, this is. Yes, for the purpose of. For the purpose. For the purpose. For the purpose of application development. Application. For the purpose of application development. For the purpose of application development. Application software. This is for the purpose of application development. Here, application software. Here, this is for the purpose of application development. Application. Yes, application app. Here, there are different kinds of applications. See, in our daily life, using different kind of applications. Yes, different kind of applications. Yes. What are the applications using in our daily life? Yes. Anyone can tell me some examples? Examples of applications. Examples of applications. Anyone idea? Of course, I'll explain. Just I'm asking your idea. Just I'm asking your idea. Applications. Examples of applications. Yes, no one, no idea. See, in our daily life, we are using many applications, right? Yes, what are the applications we are using? Tell me some examples of applications. Some examples of applications. Yes, good. WhatsApp, its application. WhatsApp next. Any others? WhatsApp is a application. See, Facebook, its application, right? Facebook. Next, WhatsApp. Yes, WhatsApp. Their applications. Facebook, WhatsApp. Next, Twitter. Twitter. Okay, next, Flipkart. Flipkart. Yes, their applications. Company websites. Company websites. Like there are different applications. Banking applications. Mobile applications. Yes, go to training application. Go to meeting like this. Zoom application. Yes. Next, Paytm. Yes, Google Pay. Yes, all these applications here. All of these things are applications. All of the applications here. Okay. So application software. This is for the purpose of application development. Yes, applications. Example. This is. Yes, application software. Yes, example. Yes, application software. Example. Best example is Java. Java. Java is a mostly used application software. Java is a mostly used application software. Java is a mostly used application software. Okay, Java is a mostly used application software. Java. Next, Hadoop is application software. Yes, Python is application software. Yes, C language application software. C++ application software. Databases application software. Yes, all these application softwares. See, in software, many technologies we are using. In software, many technologies we are using. Many technologies. Yes, more than 100 technologies we are using here. Then which is exactly application software? Which is exactly application software? Since software, there are some languages. There are some languages. Okay. If there are some, yes, some tools. There are some tools. So there are languages and tools. Next, and packages. And packages. Okay. Yes, languages. Language like C language, C++, Java, Python. Yes, like this, there are different languages. Next, tools like data warehousing tools, testing tools. Next, reporting tools like ClickView, Tableau. Next, AWS tools, big data, Hadoop related tools. Okay, like this, many tools. Okay, next, packages. There are different packages like SAP ERP package, Oracle ERP package, yes, Tally ERP, like this different packages, language, tools, and packages. Like this, many technologies we are using here. Many technologies. Yes, which is now exactly application software. Which is exactly application software. See, See, any software which is interacting with hardware components, any software which is interacting with hardware components, that is called a system software. Yes, which is interacting with hardware is a system software. Okay, so which is not interacting with the application software. Application software never interacts with hardware components. Okay, interacting with the hardware components is a system software. Which is not interacting, that is application software, which is not interacting. See, OS, only OS interact with hardware. Yeah, device drivers are part of OS. Device drivers are part of OS only. Okay, see here, except operating systems. Except operating systems. Except operating systems here, all are application softwares. All are application softwares. All are application softwares. Except OS. Except OS. See, except OS. Except OS, all are application software. Except OS. Except OS, except operations, all are application softwares. 1 second. Let me open your document here, the Java document. So this is your Java document. 1 second. Today morning updated. Morning batch updated today. Before 11. Yes, some examples are added in this document today. Some programs added. Yes. See, this is your document. Yes, this more than 500 page document. This is this document for you only. 1 second. Yeah. See, this is today talk. Introduction to software. Software is a collection of programs. Software is a collection of programs such as C, C++, Java, and SQL other programs. Software basically two categories. System software, next application software. System software, it interacts with the hardware components. So running nodes is not necessary. You guys don't write any running nodes. Running nodes is not necessary. Okay. So system software, it interacts with the hardware components, device drivers and operations. Application software. See, application software. Yeah, this is for the purpose of application development. Application software. This is for the purpose of application development. Example, C, C++, Java, .NET, ERP, and all this. See, except OS. See this, except operating systems, all are application softwares. Except OS, all are application softwares. Fine. So this is and application software. System software which is interacting with the hardware components is system software. Which is not interacting with the hardware is a application software. So except OS. Except OS, all are application softwares. Except OS. Except OS. Okay, yes. All are except OS, all are application softwares. Yes. Now let us see something about OS. Yes, to understand Java features, you must have the OS knowledge. About OS. Yes, independent of platform and portability. To understand these features, yes, we'll see something about OS here. What is exactly OS? Let us see about OS here. How OS is working. About OS. Okay. Yes, about OS knowledge. 1 second. See. Yes, operating system. Here's some question for you guys. Some question. Yes. Some question. Can we run any program? Any program? Yes, without OS. Can we run any program without OS? Answer. Say yes or no. Yes, anyone guys? Simple question, very simple question asked. Can we run any program without OS? Please respond. See, my classes are generally interactive classes. It's a friendly classes. Okay, it's not like sir and student, just like a friendly classes. Can we run any program without OS? Can we run any program without OS? Answer is no. So OS is required compulsory. Without OS, we cannot run any program. Then what is operating system? Next question is what is OS? What is OS? What is operating system? So what is OS? See, let us see what is OS. What is OS? about OS. Okay, suppose you purchased a laptop. For example, you purchased a laptop. Yes, hardware laptop, hardware, hardware. Yes, on top of hardware OS. So when you purchase laptop here, that laptop vendor will set up OS and will give us right. Will set up OS here. So operating system on top of hardware, they say operating system. Yes, operating system, operating system. Okay, on top of hardware, they say OS. So once OS setup is done, your system is ready. OS setup is done, system is ready. No system. Yes, my system is OS, right? So OS. Now this Windows OS, this OS is responsible to take your request here. This OS is responsible to take your request. Okay, suppose double click on this. OS is responsible to launch it. So double click here. Launching OS is responsible. Every request taken by the OS and here. Every request by the OS. Every request by the OS. Okay. Yes. Every request by the OS. Okay. Suppose learning some C language. Suppose you learning some C language. To learn C language, that C software you have to install on top of it. Suppose C++ learning, C++ suppose Java, Java learning, Java software. Suppose Hadoop learning, Hadoop software. Suppose database using the database of database. So database, right? Suppose Python learning. Yes, all these softwares you have to install it. Yes, all they are called as application softwares. All these are application softwares. All their application software. Yes, all their application softwares. All their application softwares. Okay. C program, yes, C++, Java, Hadoop, database, Python. Yes, all their application softwares, right? All their application softwares. These application softwares running on top of OS. Okay. These are all the application softwares running on top of OS. 1 second. Let me have some more. Yes. All these application softwares, right? These are application softwares. All are running on top of OS. So without this OS, these programs cannot run here. All programs running on top of OS. Yes, maybe C program or C++, Java, Hadoop, database, Python. To run all of these things, OS requires. So on top of OS, all are running. On top of operating system, all are running. So OS giving platform. Okay, OS just is giving platform. OS on top of it, everything is running here. So OS just is giving platform. So OS giving platform for the C language, C++, Java, and all this, right? Just it's giving platform. Just it's giving platform. Okay, that means OS acting like a platform. On top of it, all are running. So what is OS? What is OS means? Simply answer. Yes, your answer. It's a platform. Yes, it is a. Yes, it is a platform. Yes, it's a platform. It's a. It's a platform. It's a platform. It's a platform. Yes, where. So OS is a platform. It's a platform where we can run all the application softwares, all the application softwares, all the application software. Yes, OS is a platform. Okay. So OS is a platform where we can, yes, where we can run all the applications. So acting like a platform here. On top of it, all are running here. On top of OS only, all are running. So acting like a platform. It's a platform. Yes, where we can run all the application software. Okay. See, not only platform here, not only platform. Suppose, for example, C program or Java program generating some data, output generating. So first of all, output goes to OS. First of all, output goes to OS. From the OS, it transfer to output device. From the OS, it transfer to output device simply here. Okay. Yes, output of all the programs, first of all, simply transfer to OS, deliver to OS, and then transfer to output device. Suppose reading from the keyboard, input data from the keyboard. Suppose C program or Java program, reading from the keyboard. So keyboard data goes to hardware. Sorry, keyboard data goes to OS. Hardware, it's a keyboard. The keyboard data simply transfer to OS. Transfer to OS. From that, it will be transferred to your programs. So between application software, hardware, there is a OS. So between application software, hardware layer, this is a OS layer, right? So it's a middle layer, like a mediator between application software and hardware components. So mediator means like interface. So mediator called as some interface. Okay, exactly what is interface. So OS it's interface. It's interface between application software and hardware components. So what is OS? It's an interface. Next point, it's an interface. It's an interface. It's an interface. Yes, it's an interface. Interface between between application. It's an interface between application software. This is interface between application software and hardware layer. This hardware. Okay, interface. OS is interface between application software and hardware components hardware components. Hardware components. Yes, hardware components. Hardware components. Hardware components. That's it. So this is OS. What is OS means? Yes, it's a platform. OS it's a platform where we can run all the application software. Okay, not only platform here, it's acting as interface between application software and hardware components. See, application software directly cannot communicate with hardware. Okay, so application software through the OS, it communicates with the hardware. There is no direct communication. No direct communication. Okay, see here, to communicate with hardware here, yes, between application software and hardware for communication purpose, every OS has its own library. There is a library inside of OS. There is a library. Library. What is library? What is library? Library is a collection of functions, C language functions. Operating systems were developed in C language. Operating systems were developed in C language here. Yes, Windows OS in C language, Linux in C language, Unix in C language. Yes, almost all the applications were developed in C language. Okay, that OS library means it's a C language functions. OS library means just it's a C language functions. Just it's a C language functions here. Input output functions. Library. This library contains input, output functions, input output functions here. Okay, so here OS using library. So OS it communicates between application software and hardware through the OS library here, through the library here. Every OS has its own library. Every OS library is available. Okay, that library to communicate between application software and hardware components. Okay, see every OS has its own has its own library here, its own library. Every OS has its own library to communicate. To communicate between between application software and hardware components. Between application software and hardware components 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 and hardware components. Okay, and yeah, this is very important point for us. Library. So about library, yes, in Java perspective, this is important point here. See, every program, yes, all these programs like C program or C++, Java, Hadoop, yes, all these programs, first of all, links with OS library. First linking with OS library before going to run it. First linking with OS library. After linking with OS library, then communicates with hardware components. Yes, for the purpose of communicating with hardware, every program has to link with OS library to communicate with hardware component. Every program has to link. Okay, every program has to link with OS library to communicate with hardware components. Get that link, maybe statically linking and dynamically linking. Okay, suppose if it's C and C++, statically linking. C and C++ is a statically linking. Okay, suppose a Java Python is a dynamically linking. Dynamically, statically and dynamically. The topic we'll discuss next. The topic statically and practically I'll show. In C and C++, creating one exe file, that is static linking. In Java and Python, dynamically linking. Yes, I'll explain. Practical examples I'll explain. Okay, I'll write the program, how that linking, yes, statically, how it is linking dynamically. Practically, I'll show that. Practically, we'll discuss next time. Okay, yes. So every program, these programs, Every program has to link with OS library to communicate with hardware components. This is very, very important point. Try to remember this. Okay. Yes, to understand Java features. To understand Java features here, remember this point here. Yes, every program, yes, every program has to link with OS library. Link with OS library. OS library. Yes, before going to run it. Before going to run it. Before going to run. Before going to run here. Before going to run here, first of all, link with OS library. So once linked here, yes, then starts. After linking starts. So this is about OS. Yes, enough. This knowledge enough. How OS is working, this knowledge is enough here. Okay. Let us see your document here. See our document about OS. About OS. See, you guys, running notes is not necessary. Running notes is not necessary. Very clearly prepared document. Very clearly. Even single word is not missing. Even single word is not missing. Cast is there here. Cast is. So what is OS? Series create of OS. It's a platform where we can run application software. It's an interface. Okay. Next, every OS has its own library. Yes, libraries to communicate between application software and hardware components. Next, every program, see this. Every program has to link with OS library before going to start execution. Linking then execution. See this. Hardware, on top of hardware, this is OS, on top of OS, application software. See communication, input output communication, linking. Yes, all the application softwares linking with OS library, half linking then execution. So this is about OS. Okay. Yes. Now see, Java is the application software, right? Java is the application software. Java is application software. Let us move to application software. Our topic is application software. Application software. In application software, two categories: front end and back end. Front end, back end. So front end, back end. So what is front end, back end here? Front end. See here, this is front end. See here, this is some form, right? Some registration form. Yes, this is a form. Here's some form. This is some form, registration form. So filling form, we are registering it. Now this form collecting data from the right. This form data collecting is this form collecting data from us. After collecting data and yet this form collecting data, just this form collecting data, this form collecting data. After collecting data, storing at some location. So this is collecting data from us. Means this is front end. Front end. So front end interact with end users. Front end interacting with end users. We are the end users. So front end interacting with end users, collecting data and storing it back end. So front end is to collect data from end users. Yes, back end is to store the data. So front end and back end. So front end, see front end. These are interacts with end users. It collects data from end users and stores in back end. See what is back end here? Back end. These are used to store and maintain data. Examples, databases and files. Database and files. Okay. So what is Java? Java comes on the front end. Java is a front end. So our topic is front end here. Java is a front end. See, behind of this form, yes, it's a JSP program. It's a JSP. So Java server pages. Java server pages. So behind of this form, Java program is running here. The Java program taking data from you. The Java program taking data. So it's a front end. Java is a front end. So our topic is front end. Now let us move to front end here. Front end. Yes, in front end, again two types. Yes, language and packages. There are two things: languages and packages. See, package is ready-made one, ready to use. Package is ready-made one, ready to use. For example, MS Office, it's a package. ERP is package. Okay. Yes, Java is a language. Okay. In language, we should write the code. Everything is code. In language, we should write the code here. In package, no coding. So directly can use the package. In language, we should write the code. Java is a language. So let us move to languages. So Java is language. Okay. See, the way of introducing it is Java. See that introduction here. Way of introducing the Java here. See, computerware, hardware and software. So we are the software. So Java comes as software. So start with software. In software, system software, application software. Java is application software. So started with application software. Okay. Yes, in this front end, back end. Java is a front end. So started. Yes, move to front end. Move to front end. Language packages. Java is language. Now moving to languages. Yes, about language. Yes, about language. Okay. Yes, language. Yes, language. Language, just it's a media of communication, right? Language is a media of communication between two things. Language is a media of communication between two things here. Okay. Yes, like we are speaking many languages, like English, Hindi, Telugu, Tamil, something like this. Kannada, Gujarati, something like this. Why? Communication purpose. It's a media of communication. Language is a media of communication between two things, maybe two persons, or two animals, or two trees, something like this. It's a media of communication. It's a media of communication. Yes, come to software. Yes, software languages, software languages, software languages, software languages, software languages. Okay, see, software languages, there are two things. First one, yes, computer. First one, computer understandable language. Computer understandable. Computer understandable. Yes, computer understandable language. First one, computer understandable language. Or computer understandable language. Yes, computer understanding some language. Next, we are understanding some other language. Our language called user understandable language. User understandable language. Computer understandable and user understandable. User understandable means like C program, Java program. These all are user understandable. User understandable. Suppose Java program. For example, here Java program. See, it's like English language. It's a user understandable language. C program like English language. Yes, C program is also like English language. C. Yes, C program. Here the C program. Okay, like English language, right? Yes, all the English language. So these are what? User understandable. User understandable. So this looks like English language. Computer understandable. What is computer understandable language? What is computer understandable language? What is computer understandable language? 30% generation of computer. Now present generation. Present generation of computer. So what is present generation here? Yes. How many generation of computers? Any guys? Anyone can you answer this question? How many generation of computers? Of course, I will explain. Generation of computers. How many generation of computers? No idea. 11 generations. No, is something like I3, I5, I7, I9. Yes, something like he's saying here. No, that is not generation of computers. That is processor generation. Okay, yes. Generation of computers. Generation. Yes, generation. Generation of computers. Generation of computers. Generation of computers. Totally 5 generations. 5 generations. First gen. What is first generation of computer? First generation of computer. First generation. Yes. Vacuum. Yes. Vacuum tubes based computer. Yes. Vacuum tubes based computer. First generation. Okay. Yes, generally electronics getting this concept. Vacuum tubes. How vacuum tubes are working here. Next, second generation. Generation of computer. So what is second generation of computer here? Second generation, yes, good. Transistor based. You say transistor based. Yes, transistor based. Transistor based. Second generation transistor based. Transistors and vacuum tubes. Electronics subject is actually here. Next, third generation. What is third generation? What is third generation of computer? Meenakshi. Third generation. Yes, no. That is fourth generation. Microprocessor is fourth generation. So third generation is IC based, integrated circuits, IC based. Third generation IC based. Fourth generation is yes, microprocessor. It's a processor based. So this is fourth generation. This is present generation. This is present generation. Present processor based. Fourth generation. Present generation. Next, one more fifth generation. Yes. What is next generation of computer? Yeah, this will be releasing yes in couple of years. 2024. See, fifth generation. Any idea? No idea. Next coming in couple of years, coming to the market, hitting markets, new generation of computer. So integrated, that is third generation, IC based. No idea? Yes, I will explain. Don't worry. Just I'm asking your idea. See, fifth generation is AI based. AI based. Artificial intelligence based here. AI based is a feature coming. Yes, maybe 2024 hitting market. This is 2024 chance of releasing. Okay. Yes. So their generation of computers. Now currently processor based computer here. Processor based computer. Processor based computer. Present generation we are using processor based computer. Yes. What is language here? Processor understandable language. Processor understandable language. What is processor understandable language? Processor. Yes. Understandable language. Processor understandable. So what is processor understandable language? Processor understandable language. No idea. Processor understandable language. So processor understandable language. What is processor understandable language? Yes, it's a binary code. It's a binary code. Processor understandable language binary codes. Binary codes. Yes, it is zeros ones format. It's a binary code. Binary code, zeros ones format. It's a binary code. So binary codes. Binary codes. Okay, processor understandable language. It's a binary code. Zeros ones format. Zeros ones format. It's a binary code. Okay, this is called as machine language. Called as machine language. Okay. So here computer understandable language, computer understandable languages. These are called as low level languages. So first one, yes, in software, language are two categories. Yes, first one, low level language, low level languages, low level languages. Second one, user understandable, which is high level language, high level, yes, high level languages, low level and high level languages. Low level languages, and next high level languages. Yes, low level and high level. Low level, it's a system understandable language. Low level language, it's a system understandable language. Yes, it is a system understandable language. It is a system understandable. It's a system understandable. It's a system understandable language. Okay, it's a system understandable language. Okay. Yes, maybe someone may be thinking, yes, our Java class, why this trainer explaining all this? Yes, you must have that knowledge. Every knowledge you must have. Okay, not only Java here, yes, computer related, all the software related. Yes, you must gather a lot of information. You must have a lot of information, lot of knowledge. Okay, lot of knowledge. So for that purpose, even I'm explaining generation of computers also. Next generation of language, next we'll discuss generation of languages. That is different. That we'll discuss next here. Generally here, when I'm explaining any topic here, I'll give a lot of experience. Sorry, a lot of information because of my experience. My experience simply I'm delivering here. Lot of information I'll give you. Okay. Yes. So here low level languages. It's a system. Yes, it is a system understandable language. System understandable language. Yes. It is in the form of it is in the form of binary code. It is in the form of binary code. Binary code means zeros ones format. Okay, zeros ones format. Okay. Yes, it is called as machine language. It's a machine language. It is called as machine language. It's a machine language. Yes, it's a machine language. 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 It's a machine language called as machine language. Okay. Yes. Next, low level language. Sorry, high level language. High level language. High level language. High level language. They are user understandable language. User understandable. Yes. These are user understandable. Yes. User understandable. User understandable. User understandable languages. User understandable. Okay. You see, user understandable language. User understandable language. Yes, it is like English language. Yes, it is like English language. Looks like English language, like C program, Java program. Yes, all are like English language, right? C, Java, and Python are like English language. User understandable, very easy to understand. Okay, fine. So low level language and high level language. Okay, fine. The high level language, it is like English language. Okay, this high level language has to convert into binary codes. Yeah, this high level language has to convert into binary codes. See, Java program, suppose C program, it's a high level language. Java program, like a high level language, like English language, system cannot understand. System cannot understand this language here. System cannot understand. This language has to convert into binary codes. System understandable language. System understandable language. How it converts. Okay, how it converts here. Here that a high level language. Yes, high level language to binary codes. High level language to binary codes. That's how it converts. Yes, we will convert it here. No, assembly language, that is different. That is very old language. It is system understandable language, assembly language. That is different. Yes, high level language. C is a first high level language. In high level languages, C. C is a first C language. C language. C language is a first high level. C language is a yes is a first high level language. First high level language. C is a first high level language. Later all the languages. C is a first high level language. High level language to binary codes. Yes. Which one will convert here? Yes. Either interpreter or compiler. Yes. Either interpreter. Yes. Either interpreter or compiler. Either interpreter or compiler. Either interpreter or compiler converts. Converts from yes. Converts from high level language to binary codes. Converts from high level language to binary codes. Yes. Interpreter and compiler. So what is interpreter and what is compiler? Yes, interpreter and compiler. Yes, interpreter versus compiler. See, interpreter and compiler both are converting from high level language to binary codes, but some difference is there. So what's the difference between interpreter and compiler? What's the difference? So what's the difference? Anyone idea? Interpreter and compiler differences. Interpreter and compiler, any differences? Any idea? Of course, I'll explain, don't worry. So what is interpreter? What is compiler? See, interpreter. For interpreter, I'm taking some Python script. Python. Python is interpreter based language. So about test.py. Okay, Python script. Python. D-drive. Python for mnrop Python folder. Here one Python script is available. Yes, test.py file. Yes, for Python development generally, yes, we'll be using PyCharm community. PyCharm software. This is okay. For understanding purpose, yes, at the command prompt, I'm explaining command prompt, D drive, that will take to D drive, yes, D drive, mnrop Python. Okay, yeah, good, yes, interpreter is line by line, compiler takes whole program at a time. Good, CD, mnrop Python, yes, CLS, yes, here Python, test.py. Yes, notepad. I'm opening notepad. Okay, test.py. For understanding purpose, I'm explaining through the notepad. Okay, so this is Python code. Yes, Python code. Yes, like A equal 10, B equal 20. Yes, next addition, subtraction, multiplication. This is Python code. See this code. Yeah, this code. Yes, directly running. Yes, Python interpreter, test.py. Direct running, yes, executed. Suppose if it is C language, first compiling, checking for all the errors. If it is C program, compiler. Yes, let us open C also. Yes, C program. In C program, first of all, checking for errors. Suppose this is program. Yes, program to add, subtract and multiply two numbers. Okay. Yes, 1 second. Alt F, save. So this is your C program. Some C program like this. So enter first number, second number. Yes, C equal to A plus addition, next subtraction and multiplication here. See, Alt C compilation first of all. compilation, Alt C, hold and Alt key, then compile. So compile option, right? Compile success, no error. Next, run. Yes, run option. Enter key. Program executed. Enter first number 10, second number 20. Yes, addition, subtraction, multiplication. Okay. So this is a C program. First of all, it compiles. Okay. Yes, if it is compiled based, first compilation, later working. But interpreter is not like that. Interpreter is not like that. So how that interpreter is working? That is the interpreter. Interpreter. How interpreter is working? Let me explain very clearly how that interpreter is working. Yeah, this is most important topic for the software engineers. Every software engineer must have this knowledge. Okay, interpreter and compare the differences. See, interpreter. Suppose interpreter first statement. Okay, next statement. So next statement. All the statements. So next statement. Okay. Yes, next statement. There are some statements. So Python script, for example, Python script. For interpreter purpose, I'm taking Python example here. Python script. There are some statements. Yes, how it's working here. See, interpreter. So first of all, interpreter checking the yes, first line. Suppose first line is correct. First line correct. First line correct here. Yes, that first line simply converts into binary code, zeros ones format. And given to processor, just given to processor. Processor, right? Processor generating output. Processor generating output. Okay. So first line, yes, once correct, immediately executes and generating output. So first line is over. After finishing first line, then goes to second line. See, next coming lines may be right or wrong. See, next coming lines, next coming statement may be right or wrong. Interpreter never think about next coming lines. Interpreter. So interpreter never think about next coming lines. Next coming lines may be right or wrong. It won't think about it. Suppose if the statement is correct, immediately converts into binary code and generates output here. So if it is correct, execution and giving output. Next, checking for next statement. Suppose next statement also correct. Next statement also correct here. Same. Converts into binary code, generating output. Next, checking for next statement. Okay. Suppose something wrong here. Something wrong, simply stops. Yes. It won't go to next coming statements here. Suppose next coming statement, suppose there are some errors. Even that errors, it won't check for this. Any error comes, simply stops. Okay. See, if statement is correct, generating output immediately. Next statement correct, generating output. So line by line, first line completed, second line completed, but third line error, stopping here. That's it. It's a line by line. Okay, it's line by line. It takes only one line and execution. Next line taking, then execution. Something wrong, stops. Okay. Yes, let me show practically. Yes, that notepad. Yes, notepad. Test.py. Yes, open that script here. Yes, here some mistakes. Suppose here comma missing here. Suppose here double quotation missing here. Suppose here bracket missing. There are three mistakes in this. Yes, how it's working. Okay, now running this. See, yes, seventh line error. Simply stop. Any error comes, simply stops. Any error, just stop it. Just stop it here. Now correction of that errors. Correcting error. So comma placed. Under yes, saved. After save, next exit. Save exit here. Now running again here. Sorry. See here, this it will maintain history. Command prompt to maintain history. Up arrow key. I'm using up arrow key to get the previous comments. Just typing every time, not necessary. You can use up arrow key. Previously already executed. You can run directly here. That's it. See, 11th line error. Now I'm correcting 11th line error. Yes, 11th. So once error coming, simply stopping here. So once error comes, simply stopping. So once error, simply stopping. So 11th line. Yes, correction. After correction, run it. Yes, again error. 18th line error. So like this, only one error. Any error comes, simply stops. Okay. Suppose if no errors, then executing here. Okay, CLS. Yes, executed that. Okay. So what happens? Any error comes, simply stops. Any error is stops here. So it's a line by line. Yes, first line checking, then execution. Second line checking, correct execution. Third line, something wrong, stops. So this is interpreter. Okay. Same thing if it is compiler, how it's working here. If it is compiler, how it's working. Let us say about compiler. Yes, how compiler is working here. Compiler, about compiler. About compiler. How compiler working? For this, let us take C program. C language, C program, C program. So about test.c file, some C program. Test.c. Yes, how it's working here. C program checking for the first statement. If first statement is correct, even it's correct, it won't convert into binary. No, it won't convert immediately. It won't. Okay, checking for next statement. Suppose next statement is correct, it won't convert. So first what happens? C compiler, yes, compiler checking whole program from top to bottom, top to bottom. So first statement checking correct, next statement correct. Suppose next statement something wrong, yes, shows error, error at third line, error at third line. After next statement checking, next is also correct. So next like this, top to bottom. Compiler checks the whole program from top to bottom and shows all the errors, all the mistakes. Suppose here one more mistake here, some error. So compiler checks the whole code from top to bottom. Compiler checks the whole code from top to bottom and shows all errors. It shows all the errors. Interpreter is only one error. Interpreter is only one error, but it compiles all the errors. Suppose one more error like this. Okay. See this in case of interpreter, any error comes, simply stop it. Yes, practically showed, right? Practically, yes. Practically discussed. See interpreter, any error, simply stop it here. But compiler here, yes, even error comes, it go next or next. So compiler checks the whole program from top to bottom and shows all the errors, See compiler, some mistakes in this program, some mistakes. See here, suppose semicolon missing. Okay, yes, next scanf here, comma missing. Okay, suppose here bracket missing. Okay, some printf here, suppose double quotation missing. Some missing statements here. Okay, suppose here, yes, semicolon missing here. Yes, next get ch at the end, the bracket missing. See, yes, saved here. Yes, alt C compile, now compiling. See these errors. How many? 9 errors. All the errors in program here. Press any key, any key. Yes, now see this first error. See, declaration syntax error, first error. Yes, down arrow, next error. Okay, 16th line error, 22nd line error, 25th line error, 27th line error, like this all 29th line error. Yes, like this all the errors from top to bottom. 39th line error, like this all the lines errors here. It shows all errors. Compiler shows all the errors from top to bottom, showing all the errors. All the errors. Okay, compiler shows all the errors. Now let us correct all these mistakes. Semicolon. Yes, missing. Yes, scanf function here, comma missing here. Yes, next. Here this printf here, double quotation missing here. Okay, yes, suppose here get ch, bracket missing. Yes, no, saved. Yes, saved. Yes, alt C. Compile. Yes, still some more errors. Two more errors. Two errors. There are 2 errors. Press any key. So function. So this bracket missing here. Bracket missing here. Okay. Next here printf here at the end. Semicolon missing. Yes, alt C compile. Success. No run it. See here first alt C compile. Compile. Yes. Suppose if no errors, what happens? Let us see. Program compile. No errors. No errors. Everything is fine. Program compiled, no errors. Everything is fine. Suppose here no errors. Program top to bottom, everything is correct. Okay, every line, every statement is correct. No errors. No errors. No error. Yes, here no errors. So everything is perfectly right. Top to bottom, all are correct. Every statement is correct. Every line is correct here. If no errors, then compiler opens another file. It opens another file. Just opening another file. Just opening another file. Just opening another file. Just after opening another file here, yes, it converts whole this code into binary format. Compiler converts all the lines into binary format, right to another file here, right to another file, zeros ones format, writing to another file, just writing to another file. Okay, so zeros, all this code converts into binary format. All this code converts into binary format. Next binary code. binary code like this. All these codes converts into binary format. After converting to binary format, write to another file. Yes, the second file. This second file called as exe file. This is called as exe file. It's generating one exe file. Now this exe file given to processor. This exe file given to processor. So processor taking that exe file, yes, executes and generating output finally. So what happens here? Compiler checking whole program from top to bottom. Whole program from top to bottom. If no errors in the program here, generating exe file, generating one exe file. Yes, let me show that practically here. Let me show that. See math.cpp. So name of the program file is math.cpp. Backend, Turbo C backend, Windows based Turbo C. Yes, Turbo C. Yes, bin math.cpp. Yes, here math. Yes, here this is math. Remove this one here. Yes. No math.cpp. This is math.cpp. Edit. This is your program. Backend, you can see that program. Backend. So this is math.cpp file. CPP or C language, both are same. Both are same here. Now compiling. Yes, Alt C. Compiled. No error. Enter key. Now Alt R. I'm running. So when I'm running, what happens here? Run it. See. At the back end, something happened here. See this. Math.exe file generated. See here math.exe properties. See this application ex.exe. .exe file generated. .exe file generated. Okay. If no errors, first of all exe file creates, then executing here. Yes, application means exe file. Yes, math.exe file generate. Application means exe file. Okay, when you try to run it here, first of all it creates exe file. See compilation. After compilation here, next if no errors, generating one exe file like this. Generating one exe. That exe file executes. That exe file. So that exe file executed at series. First number 10, second number 20. Yes, output got it. That's it. Okay. So backend that exe file creates here. So you can compile checking for all the errors from top to bottom. If no errors, generating exe file. That exe file given to processor and generating output at a time. So compiler checks whole program and executing at a time here. Okay. Yes, interpreter line by line. See here, what's the main difference? The second file, right? In case of compiler, this exe file. Here this exe file. Here this exe file. Yes, here don't have exe file. Simple line by line directly executed. Converted execution. Conversion execution here. Conversion execution here. Okay, but here what happens when exe file generated? That exe file executed. Okay. Let us see the differences here. Okay. Interpreter compare. Let us compare the differences here. Let us compare. Let us compare the differences here. Yes, interpreter and compare the differences. See interpreter. Yes, interpreter and compiler the differences. Interpreter and compiler the differences here. What's the difference between this interpreter and compiler differences? No points. Let us see points ways. You can understand it very clearly. So first one, interpreter. Interpreter. Yes, interpreter checks the codes line by line. Checks the codes line by line. Checking code. First line checking, next line checking like this line by line. So interpreter checks the code line by line. So compile is whole program. Whole program. Yes, from top to bottom. Whole program from top to bottom. Yes, top to bottom. Whole program from top to bottom. From top to bottom. Okay. So compiler whole program from top to bottom. Okay. Next output. Line by line outputs. First line checking, then giving output here. Line by line outputs. Line by line output here. Line by line outputs. In case of compiler, what happens here? One exe file generates. That exe file executed it. So at a time outputs. So compiler is exe generating and giving output at a time. Yes, at a time output. So at a time output here. At a time. Okay. Yes, next. Interpreter. Any error comes, stopping. Means it shows only one error. It shows only one error. Only one error. It shows only one error. Compiler. Yes, compile all the errors. Compiler all the errors. Yes, all the errors. Interpreter is only one error. It shows only one error. But compile is all the errors from top to bottom, from top to bottom, from top to bottom, from top to bottom. Okay, compile is all the errors from top to bottom. Yes, next main difference exe file. Exe file. See interpreter. See interpreter. It does not generate. Interpreter does not generate exe file. Exe file. Compiler generates exe file. It generates exe file. Generates exe file. Generates exe file. Okay. It generates. Compiler generates exe file. Correct. Yes. Next here. See in case of interpreter, it does not generate exe file. So here it executes source code directly. Here it executes source code. It executes source code directly. It executes source code directly. It executes source code directly here. See source code executing directly here. See test.py directly executed. But compiler what happens here? Exe file. It executes exe file. It executes exe file. It executes exe file. It executes exe file. Okay. See interpreter based language are scripting languages. These are scripting languages. These are scripting languages. These are scripting. These are yes scripting languages. They are scripting languages. Scripting languages. Scripting language. Compiler based. They're called as programming language. Programming languages. Compiler based programming languages. Programming language. Okay, programming language. Okay. So scripting language means that language can be that program, the script can be modified anytime. Script can be edited anytime. But program you can't modify directly. It's a process. Many steps you have to follow in programming, but script directly can modify. Script can be modified directly. Yes, we'll discuss. That is tomorrow topic. How to modify script directly? How to modify the program? Yes, tomorrow topic. Yes, scripting language. All the scripting languages are interpreter based. All the programming languages are compiler based. So interpreter based languages are called as scripting language. Compiler based called as programming language. So scripting language examples. Best example Python. Python is a scripting language. Python is a scripting language. Python. Okay, next. Yes, HTML. Yes, next. Python, HTML, Linux shell scripting. Next PHP scripting here. Next Perl scripting. Next JavaScript. JavaScript is not a Java. JavaScript is different. Java is different here. JavaScript is a browser understandable language. Java is a JVM understandable language. That is different. This is different here. Programming language examples. C is the best example of this. C, C++. Next .NET, C#, the programming language. Okay, next. See, interpreter based language, no exe file. See, interpreter. Yes. See, interpreter. Yes, interpreter based language. Interpreter based language. Interpreter based language don't have exe file. There is no exe file concept in interpreter. Interpreter based language don't have exe file. Yes, compiler based here everything is exe file. Everything is an exe file. So everything is an exe file. Everything is an exe file. Okay. Yes. Interpreter based language don't have exe file. 1 second. Yes, interpreter based don't have exe file. Here everything is exe file. Okay, fine. So these are difference between these two here. Okay. Now here doubts. Maybe somebody wondering. Yes, explain about all. Where is Java? That is question. Not discussed about Java, right? Yes, reason is there. See, these are all the scripting language. They are compiler-based programming language. What is Java? Yes, Java, yes, is it interpreter-based or compiler-based? Java, is it interpreter-based or compiler-based? Yes. Let us see about Java. Yes. So what is Java? See about Java. Yes, about Java. Except Java, in other languages, what happens here? Yes, source code converts into binary code. Source code converts into binary codes. That binary code given to processor. So processor taking that code and generating outputs. That is except Java. In other languages. Yes, in Java, what happens? Yes, in Java, what happens here? In Java, first of all, Java source code converts into byte code. In Java, that byte code converts into binary codes. The binary code given to processor. So processor taking that codes and generating outputs in here. See this? Source code, byte code, binary codes. Okay, source code. Suppose a source code to byte code, who will convert? Source code to byte code. This is by the compiler. So this is by the compiler. So this part by the compiler. Source code to byte code by the compiler. See in Java byte code introduced. So why byte code introduced here? So why byte codes? Why byte codes? To make the Java as independent platform. That byte code was introduced. To make the Java as independent platform, byte code introduced. Source code to byte codes. By the compiler. Next, byte code to binary code by the interpreter. Byte code to binary codes by the interpreter. Yeah, this part is by the interpreter. Yes, interpreter. See in Java, what happens here? Yes, let me show Java example also. D drive, cd /d drive, cd test directory. See, 1 second, exit. See, D drive. In D drive, there's a test folder. In test folder, some Java program is there. Let us see how it's working. CMD, command prompt, open command prompt, D drive. In D drive, there's a test folder. Yes, dir test. What is test? It's a directory. In character interface, calling as directory. It's directory. Now change of the cd test changed to cls dir. Yes, cls dir c test.java file. Yes, notepad test.java. See, for understanding purpose, I'm using notepad. Actually, using Eclipse. Yes, test.java. So this is .java file. Test.java. So test.java. This is got a source. It's a source file. Yes, source code. Test.java. It's a source code. This source code is given to Java compiler. Java C. See now here. See dir. Yes, test.java. Yes, Java C convert. Java C test.java. Java C test.java. Compiles. After compilation, result is what? Dot class was generated. Dot class is a byte code. It contains byte code. What is exactly byte code? We'll discuss next. I'll explain. About byte code, we'll discuss next. Okay. So test.java. Yes, given to Java's compiler. Java sim Java compiler. Okay, result file is yes, tested dot class. So tested dot class file generated. Tested dot class, it's a byte code. Yes, it's a byte code. Byte code generated. Byte code, right? Yes, now this tested dot class. Byte code file. This byte code file, yes, giving to Java interpreter. Yes, Java interpreter. Java interpreter. See this. Yes, now first Java compiler compiled, generate one dot class. Now this executing by the interpreter, Java test. Yes, Java test. See this. See Java C, it's a Java compiler. Yes, source code to that byte code given to interpreter. Java is interpreter. That interpreter taking test dot class file and execute it. Execute it. Okay. So interpreter. So interpreter, yes, tested dot class file taken by the interpreter here and converting into binary code. Converting to binary code. Binary code. After that, we begin to processor. So processor taking that code here and generating outputs. So interpreter, runtime interpreter, line by line execution. Line by line execution. So what is happening here? Yes, in Java, see in Java errors, error checking, error checking by the compiler, error checking by the compiler, error checking by the compiler, error checking by the compiler. Yes, if no errors, if no errors, if no errors, if no errors, yes, generates, 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 generates byte code file, generates byte code file, generates byte code file. Okay, by generate byte code file. Okay, yes, in Java errors checking by the compiler. If no errors generates byte code file means dot class file. Okay, the dot class file executing by the interpreter. Yes, runtime. Yes, runtime execution. Runtime execution. Execution by the interpreter. Execution by the interpreter. Interpreter. Interpreter, right? Yes, interpreter. So what is happening here? Yes, errors checking by the compiler, runtime by the interpreter. So Java depending on compiler as well, interpreter. Okay, Java. So compiler as well as interpreter here. Java depends. Java depends. Java depends. Java depends on both. Depends on both compiler as well. Yes, interpreter. Okay, compiler as well interpreter here. Interpreter. As well interpreter. Okay, see here these are, yes, these are interpreter based language. They're compiler based. Compiler based, interpreter based and compiler based. But when come to Java, Java depends on both here. Java depends on both. So first, yes, Java C, yes, it's a compiler program. Error checking by the compiler. Java C test.java compiled. Now execution by Java interpreter. That's it. There are two things involving. There are two things. So Python only interpreter, C language only compiler. But Java compiler as well interpreter. Java depends on both the compiler as well interpreter. That's it. That's about Java. See, same points explain document here. See, compiler and interpreters are to convert from high level language to low level language. So differences. All the differences. Compile interpret differences. All the difference. Main difference exe file. Main, yes, it will not generate exe but generates exe file. This is main difference. Exe file. Yes, compiler based language exe file. Interpreter based language don't have exe file. Okay. See, Java depends on both. Same that explanation. Java errors checking with the compiler. If no errors, generating dot class file. A Java runtime with interpreter. Same. Java C compiler, Java interpreter. Okay. See, source code to byte code to binary code, processor output, right? Byte codes. Why byte code introduced? To make the Java's independent platform. Yes, the topic independent platform portable. Tomorrow will continue. Tomorrow we'll discuss. As I'll clear very clearly here. Now you can understand here. Okay. A Java depends on both the compiler as well interpreter. Yes. Now you can understand features of Java. Yes. Today topic is a prerequisite to understand Java features. Now you can understand Java features. Okay. Tomorrow we'll discuss about all the Java features. So once the Java features completed, next installing Java and Eclipse setup, all of these things. Yes, tomorrow about features of Java. After that, yes, installing Eclipse topic here. Okay, that's all. Yes, any guys, any doubts? Yes, any doubts? Yes, you understanding clearly topics? Yes, case, any doubts? Any doubts? Yes, if no doubts, yes, let us wind up session for today. Okay. Yes, tomorrow also same link, same time. So thank you guys. See you tomorrow.